So yeah, in this video we are looking in this problem which has stated that uh, you pick a point at random from a uniformly distributed n-dimensional ball of radius r. So now it is asked us to find what is the variance of any coordinate of that point for general n. So yeah, they are basically asked for that they chose a random point on n-dimensional uniformly distributed uh, sphere with radius r. So one thing we can say from this is that the sphere must be symmetrical as it is uniformly distributed, and as it is symmetrical, the expectation of xi will be zero because the distribution is symmetric. So each coordinate is equally likely to be positive or negative. So let's say for any xi, there will be very likely chances, like equally likely chances that minus xi exists too. So that's why the exi will be zero, expectation of xi will be zero. So as we know, the formula of variance is nothing but expectation of xi square minus square of expectation of xi. So uh, this term will get cancelled, only this term will remain. So ultimately our variance of xi will be expectation of xi square. So if we like collect all these expectations for n points for the n coordinates, so we'll get expectation of x square. And theoretically, what we can say about this is that it is expectation of square radius of a uniformly picked random point inside an n-dimensional ball. So if we if we find the expectation, it will be the volume. It will be the integration of mod x square dv upon volume. So to calculate the volume element, so dv will be the volume element, and its value will be rho n power n minus 1, rho power n minus 1 d rho into d omega, and d omega is the surface area element on the unit sphere as n minus 1. So what will the volume be? So now the volume will be integration of 0 to r integration of s n minus 1 for this term and d and 0 to r for this term. So we can separate it as 0 integration over 0 to r rho power n minus 1 d rho into uh, integration of just d omega within the limits of sn n s power n minus 1. So now if we calculate the expectation, we'll get this right. So we can cancel out these both terms as these are common, and if now we integrate, what will we get? We will get uh, rho power n plus 2 upon n plus 2, sorry, r power n plus 2 n upon n plus 2 divided by r power n upon n. So it will result in r square n upon n plus 2.